We're still going to graph sine and cosine, but we are going to do transformations. All right, so I put up here the period is the cycle length. We talked about that on Friday. All right, now we're going to review what the graph, the parent function of y equals sine of x looks like. Okay, so for y equals sine of x, the graph looks like what? Tell me what you remember about it from Friday's lesson. Yeah, it oscillates. Okay, we're drawing it in the air. It goes up and down and up and down. The question now I have for you is, what can you give me else? Like, where is it located? What can you tell me about its specific locations on the XY plane?
In between, I want to use y value of 1 and negative 1.
Okay, it oscillates between 1 and negative 1. So I'm going to put those as my y values. What else can you tell me? Thank you.
You're welcome.
What else can you tell me? How about the x values? What would make sense to put on my x-axis?
0 to 2 pi.
0 to 2 pi. Okay, so I should be going out to 2 pi. And I probably should mark at least pi over 2 increments. On Friday, we marked quarter pi increments, and that is fine as well. However, at the pi over 2 increments is where your interesting things are going to happen, like maximums, zeros, and minimums. Okay? So sine oscillates. What's the y value? On the y-axis, where does sine cross it? Where does sine cross the y-axis? Let's see, the y-axis has an x value of 0. So what is the sine of 0? 0. Sine of 0 is 0. So I'm going to cross through the point 0, 0. Okay? Now let's think through this a little bit more. So my sine value at 0 is 0 on the unit circle. If I rotate around the unit circle to pi over 2, what's my sine value?
0.
Nope. 1.
Yes.
Mm-hmm. So at pi over 2, I will have a sine height of 1. Pi over 2, swing around to pi. What's my y value or sine at pi?
Negative 1.
-1. You sure?
No, but I'm just guessing.
Don't guess.
Yes.
What's the sine of pi?
0.
Thank you. 0. What's the sine of 3 pi over 2?
Negative 1.
-1.
That's what I mean.
And what's the sine of 2 pi?
Back to 0.
Very good. So we are going to now draw our sine curve in. That is what we call the parent function if we are talking about transformations, which is what we're going to do today. Okay, so that's a parent function. We are now going to graph several transformations of that parent function. What's wrong?
Maybe like calculators, candy.
No.
Oh.
All right. Now let's talk about the parent function just a smidge more before we go on. What is the period of sine of x? Good hustle. What's
2
the
pi.
period? Good. It's 2 pi, because that's how long it takes for one cycle to perfectly complete of the parent
So is the
function.
period always going to be 2 pi?
No. We might get to it today. We'll see. Okay? If you're taking a picture, you might want to wait a second, because I'm going to add more to this.
Just taking a selfie.
Okay, the amplitude we did not get to talk about on Friday. The amplitude is the, listen close because it's kind of an ambiguous definition. The amplitude is the height in both directions away from your center axis of oscillation. So it's how high you go in each direction. Okay, so it's like the absolute value of the height that you go in each direction from your axis of oscillation, which doesn't have to be the x-axis as you're going to see today. Okay, so the amplitude I've written down right here is the height from the center axis of oscillation. So the amplitude on this graph would be what?
1.
1. Very good. You go 1 unit in each direction. You go 1 unit up and 1 unit down. So the amplitude is 1. Okay. Now let's do some transformations. Let's see what happens when I throw a 2 in here. Well, that red marker's not going to work. It's too light. What happens if I go y equals 2 sine of x? Okay, does anyone remember what putting a 2 multiplied in front of my function does to my graph from transformations in chapter 2? The 2 multiplier does what? Anybody remember? Makes it taller. Very good. So twice as tall. Okay. Anybody want to take a hypothesis about what that's going to change? Go ahead.
Amplitude.
It will change the amplitude. Very good. Okay. So 1 and -1 is now going to become 2 and -2. I will still go through the origin, but now I will hit the height of 2 by pi over 2. Come back to the origin by pi. Hit the y value rather of -2 by 3 pi over 2 and come back up to the x-axis by 2 pi. There you go. Okay. What's the period and what's the amplitude? Well, how long does it take for one cycle to complete? Still takes 2 pi for the cycle to complete. So we haven't changed that. How about the amplitude? What's the amplitude of my 2 sine x function? 2. See how you go 2 units up and 2 units down? So your amplitude is now 2. Okay. Something else that might be interesting to do is let's put a negative in front of sine. Okay, so y equals negative sine of x. Anybody remember what putting a negative out in front of the function does? Flips it. Flips it vertically, actually, because you're vertically changing the graph. You have something happening outside of the function. So you are flipping vertically. Now let's write down the period and the amplitude. Actually, let's wait a minute. Let's do the graph first. Okay. So the period and the amplitude we'll do in a second. Let's flip the graph. So opposite of my original graph, heights. So we're going to make, we're still going to be at 0, 0, but instead of being at 1 at pi over 2, we're going to go to -1. We're still going to come back to the x-axis, and instead of being at -1 at 3 pi over 2, we're going to be at +1 now. And we're still going to come back to the x-axis. There's my transformed negative sine x graph. What's the period?
1, 2 pi.
2 pi still. What's the amplitude?
1.
1. We have time. Let's go ahead and see how can so I've found a way to change the amplitude. I wonder how I could change the period length.
Do you divide?
Do you divide? Okay, divide what?
All of it?
So make it like divided by 2. That's still going to change the height because it's still happening after the function.
Do you add or subtract after sine?
What would adding or subtracting do?
Just move it.
shift it. It would shift it. So it's not gonna make my cycle happen any faster. Does that make sense?
Multiply by a fraction.
Multiply by a fraction, that's kind of like what Megan was saying a little bit ago, where we divide by a number. If you multiply by a fraction, you're still going to be changing the height. How can we change the length, Megan?
What if you square it?
What if you square it? That's an interesting idea. I don't know what squaring it would do, because it's going to change it more as time goes on. So if we change the height by multiplying the y value by something, how can we change the length? Multiply the x value by something. Yeah, I kind of led you to it. So let's do that. Okay, let's actually try this. Y equals sine of, let's put a 2 inside with the x multiplied. Sine of 2x. So here's the 2 there. Our theory is that that's going to somehow make it shorter or longer. We're not really sure which. Anybody have a guess? How many of you think that it's going to make the period or cycle length shorter? Raise your hand. Let's just take a vote. Because this should be about evenly split, I would think. Okay, how many of you think it's going to make the cycle length shorter? I just want to vote real quick. I'm not going to be keeping track of who's right and who's wrong.
Which one's right?
So that's like 6 of you that think it's going to make the cycle length shorter. How many of you think the cycle length is going to be longer? How many of you are chicken and not going to make a choice one way or the other? Yeah, that's what I thought. Okay, so try to pick one here. Let's just see how your intuition is. Okay, let's try this. Sine of 2x. So, I should probably try making a table. If I'm not sure how the shifts and changes are going to happen, I can always resort back to a table. So if I'm going to make a table of values for this green function now, it still makes sense for me to pick x values that are on my unit circle. So let's still go with 0, pi over 2, pi, 3 pi over 2, and 2 pi, and let's see if we need more than that to complete one cycle. We want to see how far I need a cycle. Again, your picture should not be any different. You should still have up, down, and back up to your line of oscillation. Should be one perfect cycle, okay? We don't have any negatives, so you don't go down first. You definitely go up and then come back down and then go back up. One perfect cycle. So here we go. That's how we know when we're done, in other words, when we have one cycle. If I plug in 0 to that, I have 2 times 0, which is 0, and then I take the sine of that. So I'm taking the sine of 0, which is what?
0.
Good. So the sine of 2 times 0 is still going to be 0. Okay, so I put a dot on the origin. And that makes sense because we did not shift the graph at all, so we should still be at the same starting point. We'll call it a starting point for lack of a better word. All right, how about pi over 2? If I plug in pi over 2 to the x value, I multiply that by 2, which gives me pi. Sine of pi is what?
Zero.
0.
Yes.
So by pi over 2, I'm back to 0 again. And if I plug in pi next, 2 times pi gives me 2 pi. Take the sine of 2 pi, and what's the sine of 2 pi?
0.
Still 0. Do you think that we haven't completed a cycle and that we need to pick some more values?
You try one more.
Yeah.
Okay,
Mine's
let's
like
try
pi
one
over
more.
4.
Huh?
Pi over 4.
Pi over 4?
Yeah.
Ah, so you think we need to pick some between these. I was asking if we need to continue going past this.
No.
So you think we need to pick pi over 4. So let's squeeze pi over 4 in here. Pi over 4 gives me what? Let's see, 2 times pi over 4 is pi over 2. Sine of pi over 2 is?
1.
So at pi over 4, I should be at a height of 1. And maybe I need to pick 3 pi over 4 to find out what's going on here. 3/4 pi, or 3 pi over 4. 2 times 3/4 pi is going to be 3/2 pi. Sine of 3/2 pi is what?
-1.
-1.
So it made it shorter.
Ah, so it finally shortened the cycle length. So you would complete 2 cycles in the time that you used to complete 1 cycle. So this thing is shortening the cycle length. Okay, so the period now is what?
Pi.
Uh-huh. And what's the amplitude?
Still 1.
Still 1. So now I've changed the cycle length instead of the amplitude. Basically, here's some summary points for you. Okay? These will be on the video, so you don't need to try to scramble to write them down. A number outside of your function makes the graph taller or shorter. A number multiplied inside the function makes the graph longer or shorter. Longer or narrower, we'll say. Okay? That's multiplying. If the number is larger than 1, then your y value, if it's outside your y value, will get taller. If the number is smaller than 1, but still positive, then your heights will get shorter. See if you can make a summary for me. How can we come up with the period without graphing it? How can we come up with the period length without graphing the function? Yep.
A number in front of sine?
Number in front of
Sine of x?
x.
Or
X only. Inside of sine. The number multiplied in front of x. What do you do with it? So this 2 right here,
Absolute value.
absolute value of it, but how do you, if we take 2 pi, which is the original period length, I'll just tell you at this point. If we take 2 pi, which is the original period length, and divide by the number that x is multiplied by, x, then your period length will be that. It'll change by that much. Okay? All right, now let's try shifting and changing. Here we go. Ready? We're now going to shift the graph. So to shift the graph, we're going to end up adding and subtracting. I'll just tell you that. Sorry, I'll get out of the way. Go ahead. We're going to use cosine rather than sine because we don't want cosine to feel left out. The shifts and changes will be the same, okay? But it's good to review cosine. So if I'm going to graph y equals cosine of x, now this is going to be a different parent function. I should probably make the graph a little bit bigger. Okay? Tell me what you know about the graph of y equals cosine of x. What do you remember from Friday? Nothing. Yeah, that's what I knew. Huh?
Well, you mean like play with the
Sure, just describe it to me. Tell me what you know.
period?
What did I hear about 2 pi?
That's the period.
That's the period. Okay, so I should probably still go out to 2 pi on my x-axis horizontally, right? That's the cycle length. Pi over 2 intervals seem to make sense to be marked. What else do you know?
The values.
The values of cosine? What's the highest and lowest cosine goes?
1 and negative.
1 and -1 still. Okay, so 1, -1. Now, so far we don't look any different than the graph we had a minute ago of sine. How does cosine look different?
It's
It's what?
I was gonna say it's more like, it's like a bell. curve.
It's a bell curve, okay, but when you graph it on the entire XY plane, it actually won't look like that. But
Okay.
the part that we graphed on Friday does look like this. That's because we only graphed the part beyond the y-axis. Okay?
Get it.
So it's shifted where? It's shifted, this graph is shifted where to come up with cosine?
Up.
Up would mean that I'm oscillating entirely above the x-axis probably.
No, down.
Down would mean I'm oscillating entirely below the x-axis.
Over pi.
Right?
Is it like
That's
1/2
right.
pi?
Shifted 1/2 pi, yeah, but which direction? Like if I take this graph, how do I have to, that's currently, this is the y-axis. How do I have to move it to come up with cosine?
To the left.
I have to move what to the left?
Yeah.
The graph or the y-axis? See what I'm saying?
Oh.
Do I have to move the curve or the y-axis to the left?
Where's the curve?
The graph.
The curve.
The curve.
I have to move the curve to the y-axis, or the curve to the left. Because if I move the y-axis to the left, it's gonna go down, it's gonna go up instead of down. So my cosine graph starts high, falls down, and goes low. Something like that. Rough sketch, okay? The cosine function has zeros at pi over 2 and 3 pi over 2. Again, you can remember that because on your unit circle, cosine is the x value. Your x value is 0 when you're at the y-axis, which is pi over 2 and 3 pi over 2 for lengths. What's the period and what's the amplitude? Period's still 2 pi, I agree with you. Amplitude is still 1. All right, the amplitude again is the height up and down from the center axis of oscillation. Now, let's graph some more. Let's see what happens when I add and subtract a number. So I can add a number outside of cosine. So y equals cosine of x plus 2. By the way, that is taking my original function and adding 2 to the height. It is not adding 2 to the x value. If I wanted to add 2 to the angle measure before taking the cosine of it, I would need to put parentheses around my x and my plus 2. Okay, so this plus 2 right here, that was asked second period. How do I know if the 2 is in the function or out of the function? It's out of the function because there's no parentheses grouping the x with the 2. Okay? So, cosine of x plus 2. Well, let's see. Anybody want to take a stab at it? How is this going to change my original y values? Or maybe I should say, how is it going to change my function? Jasmine?
Left 2?
Left 2?
Or
That's,
up 2?
it moves up 2. Okay, so it moves up 2. To add to the y values moves the y values up. Okay, so you're going to shift up 2 units. So we're going to take this graph and we're going to move up 2 units. So I'm going to, instead of being at 0, 1, I'm going to be at 0, 3. I heard it. I'm shifting up 2 units. Instead of being at pi over 2 on the x-axis, I'm going to shift that up 2 units to be at pi over 2, 2. Instead of being at -1 at pi, I'm going to be at a height of 1 at pi. Instead of being at a height of the x-axis, which is 0 at 3 pi over 2, I'm going to be at a height of what? 2. 2. And instead of being at the height of 1 at 2 pi, I'm now going to be at a height of 3 again. Everything is shifted up 2 units. So your graph looks something like this. Even your center axis of oscillation has been shifted up 2 units. So instead of oscillating around the x-axis, you're now going to oscillate around the line y equals 2. Question. What's the period and what's the amplitude? The period and the amplitude have not changed, have they? The period and the amplitude are still 2 pi and 1 respectively. Yeah.
Do you add, like, if you do the same thing, but it's to sine of x, will that move up too? Okay.
The function itself doesn't matter. What matters is what you do to the function as to how it's changed.
So,
The-
it's like
just
what we
like,
did earlier.
it's exactly like what we did in chapter 2. The parent function sets the shape of the graph. The numbers around that parent function set the location and orientation and height and length and all that kind of stuff of the function. Does that make sense?
Yeah.
You're doing transformations. Again, all that time we spent back in chapter 2 is now going to pay off. Okay, so we've moved the graph up, and we could make a table of values to kind of illustrate that. Maybe we'll do it in a little while if we have time and if you still have questions on it. However, to move left and right, let's see what we need to do. Maybe you want to take a stab at how I can move pi units? Huh? If I want to shift this graph, instead of going up, what if I want to take it and go to the right? Let's just say I want to go to the right. Go. Nuts. I want to take a stab at it? Let's say I want to move pi units. You're going to change the x value instead of the y value. So cosine of x plus pi. If I want to move that, how is that going to change my graph? I'll give you a hint. It's not going to move to the right. It's going to move to the left. Okay? So this is going to shift left pi units. Okay, so I'm going to take my original parent function and I'm now going to shift left pi units. Okay, so instead of being at 0 on the height of 1, x value of 0 on the height of 1, I'm now going to be at a height of 1 at pi. Instead of being at the height of 0 at pi over 2, I'm going to be at a height of 0 at negative pi over 2 because it shifts to left pi units. And instead of being at a height of negative 1 at pi, I'm going to be a height of negative 1 at 0. All right. 3 pi over 2 used to give me a height of 0. Now pi over 2 is going to give me a height of 0 because that's what I get when I shift left. And 2 pi used to give me a height of 1. Now pi is going to give me a height of 1. You've shifted left pi units. Now, again, you can make a table of values if you're not really sure. Let's do that real quick together. Let's try it, okay? So, because I'm getting some confused looks from some of you on that one. It's like I lost some of you, all right? Obviously, you can see that maybe it's more obvious that you can see the black graph moves left 2 to get to the blue graph, but let's see how you can come up with that. If you don't know that it's supposed to move left, how can you come up with it? If you make a table of values, okay, so let's see. If I plug in negative pi for x, Negative pi plus pi gives me 0. Cosine of 0 is
It's 0.
1. So at negative pi, I would be at a height of 1. Negative pi over 2. If I plug in negative pi over 2, what's negative pi over 2? Negative 1/2 pi. Plus pi gives me positive 1/2 pi. Cosine of positive 1/2 pi is what? On your unit circle. Cosine's the x value. 0. At 0, cosine of 0 plus pi. 0 plus pi gives me pi. Cosine of pi is going to be
1.
negative 1.
Negative.
If you plug in pi over 2, cosine of pi over 2 plus pi. Pi over 2 plus pi gives me 3 pi over 2. Cosine of 3 pi over 2 is 0. Thank you. Okay. If I plug in pi, I get cosine of pi plus pi, which is cosine of 2 pi. Cosine of 2 pi is 1. And you could keep going. However, these are the original height order that we had. That's why I started you at negative pi. If you hadn't started at negative pi, you would still see the shift. It just wouldn't be as obvious. Okay? So the period length is what?
Pi.
2 pi.
Yeah. Yep, period length is still 2 pi. It still took 2 pi units before my cycle repeated, and the amplitude is still 1. All right? It's just like everything went to the left. Pi units.
So how's that
The amplitude changes, we did that first, it's been a while, by putting a number multiplied in front of my function.
So it's only less in front.
That's correct. Well, it could be, if you had something like this, if you had y equals sine of x times 4, I mean, it doesn't really matter where you write it, but you have to multiply the function value by a number. If you divide the function value by a number, it's going to make it shorter. Okay, but it's still going to control the height. Does that make sense? Okay. On page 299 at the top half kind of summarizes all of those shifts and changes for you. Okay, so if you want a summary, that'll do it.